Newton's law of motion. Newton was the first to formulate the law of motion known as Newton's law of motion. Newton's first law of motion. First law of motion deals with bodies which are either at rest or moving with uniform speed in a straight line. According to Newton's first law of motion, a body at the rest remains at rest provided no net force acting on it. Yes. Thus, this part of law is true as we observe that objects do not move by themselves unless someone moves them. For example, a book lying on a table remains at rest as long as no net force acts on it. Similarly, a moving object does not stop moving by itself. A ball rolled on a rough ground stops earlier than the rolled on the smooth ground. It is because rough surface offer greater friction. If there would be no force to oppose the motion of the body, then the moving body would never stop. Thus, Newton's first law of motion states that a body continues its state of rest or of motion in a straight line provided no net force act on it. Since Newton's first law of motion deals with the inertial property of matter, therefore Newton's first law of motion is also known as law of inertia. We have observed that the passengers standing in the bus fall forward when its driver applies brakes. Suddenly, this motion is also known as law of inertia. We have observed that the passengers standing in the bus fall forward when its driver applies brakes. Suddenly, it is because the upper part of their bodies tend to continue their motion while lower part of their bodies in contact with the bus stop with it. Hence they fall forward. Newton's second law of motion. Newton's second law of motion deals with situations when a net force is acting on the body. It states that when a net force acts on a body, it provides acceleration in the body in the direction of the net force. The magnitude of this acceleration is directly proportional to the net force acting on the body and inversely proportional to its mass. If a force provides the acceleration in a body of mass m, then we can state mathematically that is directly proportional to F is inversely proportional to 1 over m is inversely proportional to force over meter. F is directly proportional to ma. Putting k as proportionality constant, we get F is equal to k ma. In SI units, the value of k comes out to be 1. Thus, equation 3.2 becomes F is equal to ma 3.3. SI unit of force is Newton. According to Newton's second law of motion, 1 Newton on N is the force that provides an acceleration of 1 meter per second square in the body of mass of 1 kg. Thus, a force of 1 Newton can be expressed as 1 Newton is equal to 1 kg multiply 1 meter per second square, or 1 Newton is equal to 1 kg meter per second per square. Here is example 3.1. Find the acceleration that is produced by a 20 Newton force in a mass of 8 kg. Solution is here. M is equal to 8 kg, F is equal to 20 Newton, A is equal to find. Using the formula F is equal to MA 20 Newton. Using the formula F is equal to MA, the previous formula, 20 Newton is equals to 8 kg multiply acceleration. Acceleration is equal to 20 Newton over 8 kg. Acceleration A is equal to 2.5 kg meter per second square over kg is equal to 2.5 meter per second square. The acceleration produced by the force is 2.5 meter per second square.